Okay, we're going to work on dividing polynomials. Okay, dividing polynomials. Two ways to do it, long division, and it is just like regular numeric long division. It works the same way. How many times does something go into something else? Write it down, multiply it, then you end up with the remainder at the end, or not if it goes in evenly. It works exactly the same as regular long division. Or at least it's the same algorithm. An algorithm, a step-by-step process to solve a problem. That's what computer programs are. They're algorithms. Okay. Synthetic division simplifies long division for expressions of the form x plus a or x minus a. Synthetic division is another way of doing long division. Okay, it's a slightly different method. It doesn't always work. You can't always use it. Okay, when dividing by 2x plus 1 or 3x minus 2 or something like that, where you have like something in front of the x, it's not just x by itself, you must use long division, although there is a note here which is true. You don't have to. You can use synthetic division, but it involves fractions, and it's not worth it. Okay. When dividing by x plus 3 or x minus 4, where I have an x only, where I have 1x plus or minus something, synthetic division actually works easier. So they're two slightly different processes. We're going to cover the long division today. We'll do the synthetic division when we're together on Wednesday. Okay, because I don't want to do it all in one day. I want to give you a quiz if I can, and we'll go from there. Okay, questions? All right. So, long division. Okay. And I think you guys have, do you guys have the same matchup that I do where you only have 2 problems? Yeah. Awesome. Because I tried to give a little more room. There were 4 problems per page. Man, there wasn't enough room to do the work. Okay, so I tried to change that. I'm glad that worked for you guys too. I couldn't remember if I printed that up. Long division. What I'm doing is I'm taking 4y squared plus 23y minus 16 and dividing it by y plus 5. And I might have a remainder. I might not. Probably, actually, I will on this one. I know I will. Okay, 5 does not go into 16. I will have a remainder. Okay. Your first step, and you do this step by step. When you do regular long division, you don't try to, how many times does it go into the whole thing? It's how many times does it go into the first item? Okay? Now, when I decide by long division, the plus 5, the first step just kind of goes along to the right. Okay? I want to know how many times does y go into 4y squared? What times y gives me 4y squared? 4y. Okay? 4y times 4y. 4y times y gives me 4y squared. Does that make sense? Okay. So 4y times y gives me 4y squared. Where did I write it? I wrote it above the y terms, not the y squared terms, above the y terms. Just like when you did long division, if it doesn't go into the first number by itself, it goes in the first 2 numbers, you put it over to the second number that you're going into, right? Same idea. 4y times y squared gives me 4y squared. Now I concern myself with the 5. 4y times 5 gives me plus 20y. Now, when you did long division, what does it go in? You multiply it right underneath, and then what did you do? You subtract. You do the same process. You subtract. Minus 4y squared minus 4y squared is gone. That's our goal, is to get rid of that first term. I don't care about what happens in the second column, but this first column needs to get cleared. 23y minus 20y gives me 3y. So I did my subtraction. Now, if I have more stuff left, in regular long division, if I had more stuff left, what did I do? I brought it down. I do the same thing here. I take this negative 16, and I bring it down. Okay, you see what's going on here? It works just like regular long division, same process. Now, once again, the 5, I don't care about the 5 when I'm doing how many times does it go in. I don't care about the 5. It's just along for the ride. How many times does y go into 3y? What times y gives me 3y? 3. So I have plus 3. 3 times y gives me 3y. 3 times 5 gives me 15. And then what do? I subtract. So 3y minus 3y is gone. Negative 16 minus 15. Negative 31, right? Negative 16 minus 15 is negative 31. Does y go into negative 31? No, there's no y's attached to it. Nothing times y is going to give me that. So this is my remainder. That's my remainder. It's what's left over. When I get done at the end, I have a remainder. Now, there are 2 ways to deal with your remainder. 2 ways to write my final answer. How many times does y plus 5 go into 4y squared plus 23y minus 16? It goes in 4y plus 3 with a remainder of negative 31. Or 4y plus 3 minus 31 over y plus 5. Either one of these 2 answers I will deem acceptable. Both of those are valid answers to this problem. It goes in y plus 3 times. But I have a remainder of negative 31. Now, how I deal with that remainder? I can either write remainder negative 31, or we do the same thing we often did beforehand, put a fractional as our end. How many times does 2 go into 5? It goes into 2 1/2 times, right? Because it's divided, you get a remainder of 1, 1/2. That's where the 1/2 comes from. Same idea. With the remainder divided by our divisor, what we're dividing by. Okay, what did we divide by? We divided by y plus 5. Our remainder is negative 31. Negative 31 over y plus 5. Either one of those are acceptable answers. Okay? You with me so far? Yeah. It's not too bad. It does get more complicated, but it's the same algorithm. The algorithm is the same. The steps are the same every time, no matter how big it is. So I step up to the next one. 3x into 3x squared. What am I multiply 3x by to get 3x squared? X by x. Okay. X times 3x plus minus 1. X times 3x. 3x squared. X times negative 1 minus 1x. And then what do? I subtract. 3x squared minus 3x squared. No more x squareds. That's my goal. Anything else, I'll deal with later. But I have to get rid of that first term. So it's gone. 11x minus negative 1x. 12x. Right? 11 minus negative. Watch your minus your negatives. So I get 12x. And then what do? Bring down the negative 10. How many times does 3x go into 12x? 4 times. 4 times 3x gives me 12x. So plus 4. 4 times 3x, 12x. 4 times negative 1, negative 4. And then what do? I subtract. Once again, that first term needs to disappear. That's my goal. 12 minus 12, gone. 12x minus 12x, gone. No more 12x's. That's my goal. Anything else? It's just what's left over. Negative 10 minus negative 4. Negative 6. Negative 6. You got to watch negatives and positives when you're subtracting here. Got to pay attention. This is probably the trickiest part, is paying attention when you're doing the subtraction. So my final answer is x plus 4 with a remainder of negative 6. Or, alternatively, and I'm not going to do this every time, x plus 4 minus 6 over 3x minus 1. Either one of those, perfectly acceptable. Okay? Questions so far? Like I said, it's same algorithm, same steps as doing regular long division. You just got algebraic variables in there. Okay? All right, so let's try this next one. Try the first number. Do the very first step. Don't go past that first step. Just in case you screw up. I don't want to screw up the whole thing. How many times does 2b go into 2b cubed? Write that down and multiply it and subtract. Just do that first multiplying and subtraction step. Don't go any farther than that without me. Okay, how many times does 2b go into 2b cubed? V squared. V squared times. V squared. So v squared times 2v, 2v cubed. Good. Those need to be the same. V squared times 1 is plus v squared. And then I subtract. 2v cubed minus 2v cubed gone. Negative 7v squared minus v squared gives me negative 8v squared. And then I bring down my negative 10v. And then I go back, do the next step. Same process. Do that next step, same process through. Step by step. Tough getting your brain going after a week off, isn't it?
Yeah.
Yeah. This isn't necessarily a difficult process. It's just one you have to be extremely careful with. You have to be very careful with what you're doing. It's very easy. Lots of steps through solving a problem. Very easy to screw up. Very easy to screw up. Not difficult, but a lot of places to make mistakes. Okay. So 2v goes into negative 8v squared minus 4, right? Minus 4 times 2 gives me negative 8. So it goes in minus 4v times, okay? So negative 4v times 2v gives me negative 8v squared. Negative 4v times 1 gives me negative 4v, right? And then what do? Subtract. Okay. Negative 8v squared, good. Negative 10v minus negative 8v. Negative 10 minus negative 4. Don't be afraid to write it off to the side. Negative 6v. And then bring down the plus 5. Yeah, don't be afraid. And I've done this so long. For me, it's not that hard to do, but I still do this in my head. Don't be afraid to write it off to the side like this. You're not sure. It's easy to get screwed up when you're subtracting negatives. It's easy to screw up. Don't be afraid to write the problem off to the side and then do it there. Not a big deal. Okay, pull out your calculator. Okay, negative 10 minus negative 4. Oh, that's negative 6. I'm fine with that. You're allowed to use calculators in this class. Please feel free to use them to do simple stuff like this if you're not sure. Okay, you have the tools. Use them. Okay, really. I cannot stress that enough. Okay, 2v into negative 6v plus 5. Go ahead and do it. Finish out the problem. Okay, 2v goes into negative 6v. How many times? Negative 3. Negative 3 times 2v, negative 6v. Negative 3 times 1, minus 3. And then I subtract. 5 minus negative 3 is? 5 minus negative 3. 8. Once again, this is where you're going to screw up every single time. I guarantee it. And if you do it on the first one, what happens after that? They're all wrong after that first step. You absolutely must be careful when you're doing this part of it. This is where almost all the screw-ups come from. Okay? So my final answer would be v squared minus 4v minus 3 with a remainder of 8. Okay, uno mas together. Same process, first step, do the same, first step, the same. How many times does n go into, ooh, wait, time out. Time out. Got a problem. Got a serious problem going on here. Okay. My dividend. Divisor, dividend. Okay. Is not proper. It's written in standard form, isn't it? It's in standard form. Highest power descending. Here's the problem, though. When you're doing division, long division or synthetic division, either one, you must make sure that all of the powers are represented. I don't have an n to the fourth. I don't have n to the first. Yes?
What would the yearbook stack? Can we borrow Carissa?
Carissa's not here.
Okay.
She's not here. So, I got a problem. I don't have an n to the fourth, and I don't have an n to the first power. Every power from the highest power down needs to be represented when you're doing your long division. So here's what I have to do. I have to rewrite the problem. And minus 3 into n to the fifth plus 0 n to the fourth minus 2n cubed minus n squared plus 0n plus 2. You have to have every power represented. Carrie? Okay. You must have every power represented. If it's not there in the original problem, you have to have a 0 of that variable of that power. Now you can do your long division. You can have a bigger answer, but you have to have them represented or it doesn't work. Okay? So, same process from here. How many times does n go into n to the fifth? 4 times. N to the fourth times. n to the fourth. See why I have to have an n to the fourth? If I don't have 0 n to the fourth when I do my subtraction, I don't have anything to subtract from. I have to have that in there. It wouldn't have worked. I would have had n to the fourth line up with n cubed, and that doesn't work. They have to line up. Okay? So multiply it. I get n to the fifth minus 3n to the fourth. And then I subtract. N to the fifth minus n to the fifth is gone. 0 minus negative 3. Or n to the fourth, 0 n to the fourth minus negative 3 n to the fourth. How many n to the fourths do I have? Minus a negative 3. Minusing a negative, that makes it a positive 3. 3n to the fourth. And then bring down minus 2n cubed. Repeat. Rinse and repeat. How many times does n go into 3n to the fourth? 3n cubed. This is an easy one. Plus 3n cubed. 3n cubed times n, 3n to the fourth. 3n cubed times negative 3 gives me negative 9n cubed. And once again, what do? I subtract. 3n to the fourth minus 3n to the fourth gone. Negative 2n cubed minus negative 9n cubed. We got one. 7n cubed. And then you bring down the n squared. Please continue and finish the problem. Just information. So continue, finish the problem. 3 times 80 is 240. Okay, so we left off here together. N goes into 7n cubed, 7n squared times. So I get 7n cubed minus 21n. Negative n squared minus negative 21n is positive 20n squared. Goes in there 20n times. Bring down to 0n. 20n, ooh. Yeah, I screwed up. There's always a mistake somewhere. I screwed up. This is not right here. This is not right here. And the reason why, and I'll rewrite this a little bit better. It's 20n squared plus 0n. It's my sloppy handwriting. That was really my sloppy handwriting. Subtract. I get 60n plus 2. And that goes in. Come on, slide up. There we go. Goes in there 60 times. Which gives me 60n minus 120. 160. Ah! Yeah, I should know from my skateboarding days that 180, right? Kidding. My skateboarding days, I was never that good. Okay. So my final answer, oh my word, n to the 4th plus 3n cubed plus 7n squared plus 20n plus 60 with the remainder of 182. Awful lot for Monday after a break. I don't care. Your turn. Do these two. All right. So b goes into b cubed, b squared times. B squared times b minus 1 is b cubed minus b squared. I subtract negative 4b squared minus b squared gives me negative 3b squared. Bring down the 2b. B goes into negative 3b squared, negative 3b times. Negative 3b times b is negative 3b squared. Negative 3b times 1 is plus 3b. Subtract. 2b minus 3b is negative b. Bring down the 3. B goes into negative b, negative 1 times. Negative 1 times b minus 1 is negative b plus 1. Subtract. I get 2. So my answer is b squared minus 3b minus 1 with a remainder of 2. And then same thing on the next one. Y goes into y cubed, y squared times. Oops, put it in the wrong place, didn't I? Y squared. Y squared times y plus 2 is y cubed plus 2y squared. Subtract. Y cubed minus y cubed gone. 7y squared minus 2y squared gives me 5y squared. Bring down the minus 5y. Y goes into 5y squared. 5y times. I get 5y squared plus 10y. Subtract. 5y squared minus 5y squared is gone. Negative 5y minus 10y. Negative 15y. Bring down to negative 6. y goes into negative 15y, negative 15 times, negative 15y minus 30, subtract, negative 6 minus 30 is 24. So I get y squared plus 5y minus 15 with a remainder of 24. Questions? Okay, 2 more problems. You got 5 minutes. Remember, on the last one, it goes from p cubed to 9p. What do I need to put in there? 0p squared. 0p squared needs to be added in there. You got 5 minutes. Okay, so on the first one, you have no remainder. Goes in evenly. So you get u squared plus 3u plus 1. The last one, remember you have to add a 0p squared into the problem. So you have p to every power. And you end up with p squared plus 4p plus 7 with the remainder of 18. Questions? Okay, we will finish this tomorrow.